We present a story version control and graphical visualization system to enhance collaborative story authoring. Here you see the version control system architecture. Story repositories are centralized on a server and can be accessed online by both story editing as well as story visualization tools. We will first demonstrate the functionalities of the story editor client. Author Alice creates a new repository called Demo Repo 1. She clicks Checkout to create and initialize the repository. Alice authors an appear event with a ghost participant. Then she opens the version control dialog again, enters a commit message, and commits the story to the server. User Bob then checks out the same repository. He can now continue working on the story. He decides to remove the appear event with the participant. Before he commits, he can inspect a preview of the changes in the diff to base view. The red highlighting indicates that these objects will be removed. He commits the story. Alice clicks Update. Bob's changes are now downloaded, and she sees a preview, a visual diff to her current story. In this clip, we demonstrate how a conflict can be resolved. User Alice removes the appear event, adds an inhabit event, and commits the story. At the same time, and without updating first, Bob adds a participant to the appear event. This will cause a conflict. He also adds an investigate event. The system does not let him commit because his base revision is too old. Instead, he clicks Update. Since a conflict is present, the conflict resolution tool is launched. Bob can inspect his operations performed in the base story, Alice's operations on the base story, the current conflict highlighted in green, and then choose if he wants to keep his operation, insert the participant, or choose Alice's operation, remove the event. He decides to keep his operation. The remaining non-conflicting operations are merged. The story contains now all three events. With the visual editor, an animated story can be automatically generated from the authored story definition. Horizontally aligned events happen at the same time, while the vertical axis indicates time progression. The author creates a story where a scientist enters a castle, and soon later a ghost appears. We demonstrate the possibilities of our media-agnostic abstract story representation in SVC by creating stories of various media types. Here, images from the open-source movie Tears of Steel are used as events. The author creates a story in the usual fashion. From the story definition, we manually create a comic representation and a movie representation. Parallel events are shown side by side in the movie. The author makes some changes to the story, and the corresponding movie is shown. Finally, we demonstrate the visualization capabilities of our system with the standalone graph visualization tool integrated in Gephi. The author downloads the entire repository. First, he generates a story-centric graph. In a story-centric graph, beat and event nodes form the graph layout. Author contribution is aggregated over a revision interval and displayed inside the node as pie charts. He then generates an author-participant relation-centric graph. This graph visualizes the relations between authors and participants. Existing features in Gephi are used to lay out and explore the graph. Finally, the author generates a meta-relation graph. This graph characterizes the relation among authors based on how they interact with beats. Thank you for your attention.